All right, well, if you're just joining us, thank you and welcome to our Boston.NET architecture group. We're a group that has been around now since actually late 2004, so a long, long time. We've been uh, really meeting for a long time in different locations, Microsoft offices and so forth, but really over the last 2 years, we've been meeting virtually. And so this allows opportunity for a number of folks to join us who may not be in the Boston area specifically, which we're think is really cool. Opportunity for for people to join us as part of the session, but also to have speakers who are not in the Boston area and visiting with us in person. And that includes our speaker tonight. So I want to welcome Sean Whitesell, who is going to speak to us about microservices. Sean, welcome.
Thank you. I appreciate being here. This is a great opportunity. I've not spoken to this group before, so I appreciate that. And I'm trying to share my screen. It doesn't see I'm available to do that just yet. But yeah, my name is Sean Whitesell, president of the Tulsa.NET user group, have been for 13 years, I think, and then helped out for several years prior to that as well. So it's been a lot of fun. I really enjoy helping user groups, both my own as well as many of the helping other user groups in various ways, etc. And so tonight we're going to talk about microservices, and I really like that this user group specifically is about architecture and not just programming, because microservices, as we're going to talk about, is an architectural pattern. And there are sub patterns inside there, but it's more about microservices being in architecture than it is about programming. So the goal is to talk a lot of details and to really show that microservices architecture takes a lot more consideration than you may think. And if you think you're just going to go ahead and get started because you hear these buzzwords, you're better off not doing microservices. However, if you are interested, you want to jump in, you'll learn a lot more about them, and you're willing to put forth a lot of the energy and time and money that's involved, then the architectural pattern may work out well for you. So we're going to be discussing what are microservices, why should you use them, when should you not. We'll talk a lot about the challenges, and then we'll go over a high level decomposition.
Was that?
And
Sorry, let me see if I can mute everybody.
yeah, I see somebody else is already trying to draw. Playing with the gadgets on Zoom. If you do have questions, you're more than welcome to put them in the chat. I can quickly read those, and happy to address questions as we go through. And at the end, we can open this up a little more and to discuss other questions that come up. So, like I said, we're going to talk about what are microservices, why should you use them, when should you not. Well, we're going to talk a lot about the details that make up the challenges. Then we're going to do a high level discussion about some decomposition into microservices. So to begin with, what are microservices? Well, a microservice is, like I mentioned earlier, it's not about programming, it's about architecture. And there have been many answers as to what is the question to the question, what are microservices? Well, one of the things I did back, this is pre-pandemic, when I was in person, I would ask the group, I said, what are some answers of what is a microservice, and get a few answers in the audience. And it always differed. And Martin Fowler's got great answers out there, and several others. I'm going to go ahead and provide an answer as well. And that's simply that a microservice is simply a tiny monolith with a tight focus on a domain. It's not about the size, not about the code, the size of the code. It's about the focus. And we're going to talk a lot about that throughout this talk. The idea is that when you look at a domain and you are going to be the judge of what is that domain, how big is it, and then deciding should the functionality be exposed via a microservice. And so there are several of the tenets about microservices, such as a microservice is an independent application. And you will hear me repeat that over and over throughout this talk. A microservice is an independent application that is deserving of all the love and care as any other independent application. And unlike a lot of your code that may run in a monolith that goes to talking across memory boundaries, just calling to a memory location, microservices communicate over a network. And we'll discuss how they communicate either directly or by use of messaging, but either way, a network is involved. And that's actually a con because it adds latency. And microservices have a single responsibility. That microservice should exist for a single reason. It should not contain too much functionality across more than one domain. So we're going to, and again, we're going to look at all these details as we go through. Owned by one team of developers. If you have a microservice that is owned by multiple teams, then you will end up with conflicts of what language to use, coding styles, who's going to support what, etc., and certainly timelines, deadlines, etc. So you're better off to have a microservice owned by one team. Now, of course, that one team can own multiple microservices, and that just depends on how much there is to maintain. And since microservices are independent applications, they must be individually deployable, meaning that you should not have tight coupling on code that is tying together that microservice to anything else, a monolith or another microservice. And as I mentioned before, microservices is an architectural style. So when we're talking about monolith, what exactly is a monolith? Well, a monolith is that code base, that a compiled in code base that is shipped and or deployed all at once, and it contains multiple functionality across multiple domains. When you get into microservices, you're likely to either extract some functionality into a microservice away from a monolith, or bring brand new functionality to a microservice that has never existed in a monolith or anywhere else. Rarely will you do a total migration to from a monolith architecture to a microservices architecture. Now, it has been done. It's very costly, and we'll discuss a few of those companies in just a moment. The microservice architecture is an implementation of distributed computing. The picture here is to kind of picture out or denote the idea that there's 5 microservices, but there's also multiple instances of those microservices, and they're communicating across with each other. The purpose of that is when you see the amount of computing requirements that you have, you're trying to distribute that over essentially multiple servers. Now, could be another server, it could be another, maybe a Docker container, something like that. But the idea is that you're spreading the computational needs across many other resources. So why should you use microservices? Really, you're going to see a lot of the best benefit is when you have to deliver business functionality quicker, safer, and with more stability. Meaning that, for example, the boss comes in and says, well, we've got a new product we've got to get out the door. And because time is money, the sooner we are to that getting this into production, the sooner you're going to be able to reap the benefits of market share, something like that. And then you have to tell them, well, it's going to be at least 6 to 9 months, because as soon as we touch the code, it breaks. And we've got other issues, etc. So you're likely to look at microservices then and going, well, then I need to touch that monolith as little as possible because there's too much tight coupling involved. There's too much code fragility, etc. So it really, and the point of this slide is to point out that it's really about trying to help the business functionality. Now, some other tenets about microservices. There is team autonomy. So when you're developing your microservices, you get to choose the best programming language for the job. For example, one of the projects I've been on was primarily in C#, but when they started doing analytics, they're like, well, we're going to get our analytics people involved and they're going to develop their stuff using Python. It's just a better language than C# for doing data analytics. Not to say C# can't do it, but most of the time you'll see Python used. So it allowed the opportunity to use a different programming language that was to fill those specific needs. As well, that team then can focus just on the development of that. They don't have to learn so many other various things. You can have that tight focus on for that development team. And if you're already in an environment that's using Agile or Kanban, it works really well with the development of microservices. And a microservice should have that single responsibility, should exist for one reason. For example, what if we have a microservice that's to handle all of our accounting functionality? Well, it should not have accounting as well as scheduling or as well as handling warranty type things. I'm just picking ideas. That microservice should do one thing and one thing only. So let's say it does its accounting. And then after a while, you realize, well, we've got differences and we've got a growing amount of functionality here. What we really need to do is split this even further. So it's not a bad idea to have a microservice for accounts payable and then another one for accounts receivable, because you may have that need to split those out even further. You've defined that what we thought was a single responsibility now kind of is colluding with each other, and we can split those out even further. That's okay. There's nothing wrong with that. And then what you also see then is, well, if I have an accounts payable microservice versus an accounts receivable microservice, they should not be tightly coupled. You should be able to deploy them on their own schedule, independent of any other service or the monolith. So let's go on to the next one, which is scalability. Microservices allows you the opportunity to scale the microservices independent of others. So not only do you get your choice of programming language, but you can also say that this microservice has really strong needs for CPU and memory, and where this other microservice is not as demanding. Maybe it's not called as often. You get the choice of what kind of servers that you want to use. If, say, for example, if you're going to use Azure, should you use the D series or should you go E series? You know, are you computational heavy? Are you memory heavy, etc. So, and as well, if you know, are some of the microservices going to be hosted as an Azure function or an AWS Lambda? You get to have that choice. Microservices also gives you fault isolation. The idea here is, let's take, for example, when you go to Amazon and gonna find a product, you're going to see the description, you'll see the picture, you're going to see reviews about it, you'll see suggestions of other products that are in that realm or that category. Well, those are fed by multiple microservices. But what if the microservice that says and gives you the reviews, both the stars and the comments and stuff, what if that goes down? Should that stop a customer from being able to purchase the product, even if they can't get to all the other details that usually are on the page? So what you have is a way of depicting out some of your business processes and used by different microservices. And you can see how if a microservice, and here in this C, the microservice, if it happens to have a problem, well, the functionality for D and E are going to be able to continue and work as intended. Now, there's obviously some caveats to that. If the person can't log in, well, then they can't purchase. So it definitely has other things that can have higher priority. Now, I mentioned earlier that there was some companies that have gone and spent the time, money, and effort to go from a monolith architecture to a total microservices architecture. And three of them is Amazon, eBay, and Netflix. Now, they've done it. They've had both their mistakes. They've sent something out to production to have to pull it back in. They've had learning curves. Netflix has even created some open source software, one of which is called Eureka. So there's a lot of lessons that they've gone through to making a microservices architecture and going to a total microservices architecture. They no longer have a monolith at all. That's great, but they spend a lot of time, money, and effort to do that. And so let's quickly discuss, why should you not use microservices? Well, quite frankly, they're just hard. Now, it sounds like a cop out, because really, to do good programming, that's hard too. But the idea is that you cannot just do a microservice, send it out in production, and think you're done. There's so many other pieces involved. If your monolith is simply too small, now obviously you're the judge on this one, but if that monolith is just simply too small to break apart, and it's just easier and cheaper to put in feature flags and then make multiple instances of your monolith, and you're using feature flags to govern what that instance of a monolith is processing, that's not a bad way to go. And you might even do that on your way to developing microservices. And when you're getting into your code and you're going to think about pulling out some existing functionality or tweaking some of the other stuff, and you've got too much coupling in your code, you're going to have to spend a lot of time refactoring that first before you're going to really see benefits of going to a microservice. And as you're building out what you're going to want to do, you're going to have the team that's prepared to do it. And if that team is just unwilling or not ready, need a lot more education on some things about the architectural pattern, then you're going to want to cross that bridge first before you start trying to send out a microservice to production. And if you don't have a support structure in place, then you're going to have a lot of challenges with that as well. For example, if you, I'm a big fan that if you're the team that developed it, you need to be the team that supports it, because it's not really fair that if you develop the microservice, then another team has to support your code changes. So you're going to have that way of handling in the your bug tickets, etc., and building that into your timeline. And I mentioned this again, is that high cost of time and money to really build out microservices well. So let's talk about some of the challenges. And as I mentioned, the cost of time, money, learning, you're going to spend a lot of investing. But as you're working out your microservices, you're going to have to work out, how are they meant to communicate with each other? Should we do direct RPC style calls where something has to know the IP address of the other microservice? What if we did messaging? We looked at messaging patterns. Should we do synchronous calls or asynchronous calls? Should we use PubSub? Or things like competing consumers and things like this? You're going to have to work that out. And because microservices are independent applications, they're going to need all that love and attention, just like any other independent application. That includes building out a continuous integration and continuous deployment pipeline per microservice, as well as it should have its own code repository. That way it can be its own, and you do not have the coupling with other microservices or the monolith, etc. And I mentioned that networking is not my job. Well, as you get into microservice development, it is starting to become your job. At least you need to be aware of it and understand a lot more of the details about it. Specifically, and I mentioned on the OSI model, layers 4 and 7. I'll cross that in the next slide. Security, again, more of an issue for developers. We need to understand how are things going to communicate, and should we use some sort of like a TLS for encrypting the communication? Should we use OAuth for governing who can call that microservice? The quick analogy that I have is imagining that you have a microservice that is there to process your paycheck. Do you want anything else to sniff that network and get a hold of information? And would you like to be able to control what other processes in the organization is allowed to call that instance of that microservice to get and control information? Now, another thing too is that when we talk about securing that communication, you think, well, it's on a private network. We don't have to do that. The TLS is used for the public stuff. Yeah, but you also may be using maybe an NPM package or a NuGet package, something like that. You may be bringing in third-party code, and what's to how do you know that there's no rogue code in there sniffing the network and trying to send that information out. So not only do you want to secure the network traffic inside even on a private network, but also control if anything should ever be talking out to the internet. And if you've got something that's only meant for internal calls and it has internal replies and that's it, then you want to set up some sort of a network restriction that prevents it from ever talking out to the internet. And common code, where we say the DIY principle, don't repeat your dry principle, don't repeat yourself. I'm going to show you in just a few slides where when we start to have that kind of a common code, that it's actually going to restrict your microservices. So now we're going to actually look at duplicating code, and I'll cross that bridge in just a moment. So this is the Osi model. A lot of anybody familiar with networking is aware of this model. And I'm just pointing out the ones that are in particular to what you'll be dealing with is like on layer 3s, your IP addresses, or ICMP, which is for ping. Layer 4, TCP and UDP, those are the type of protocols for understanding that traffic of that data, but all the way up to layer 7, which is going to be the data layer, where the data in the package is going to be dealt with by your application. Why do we need to know? Well, if we're going to have, if we're going to use a load balancer, for example, we're going to use an Azure load balancer, and so it sends traffic over to the next instance of your microservice. Well, it has to know which ones are available. That way you don't have to have a hard-coded list of IP addresses. It allows you the flexibility of microservices being swapped in and out. And certainly if you're using something like Kubernetes, you can use a service there to be that as that load balancer. Well, as you send traffic across to different microservices, the first balancing piece that it's going to do is at layer 4. Like I said, with Azure Load Balancer as an example, in AWS, that's going to be the application load balancer. Whereas in AWS, you got the network load balancer. I apologize, I said that wrong. In AWS, the network load balancer is layer 4. In AWS, there's an application load balancer that's at layer 7. In Azure, that's an application gateway. And another way to think you can use is Nginx. Nginx is a layer 7 load balancer. Another way to remember this too with layer 7, if you're familiar with the MVC pattern, such as ASP.NET MVC, the one letter they leave off, which is R for routing. Well, as the calls come in, they get routed to the proper controller that's going to deal with it. That's done at layer 7. So it's just being aware of it, how they communicate. And as you work with anybody that's building out the infrastructure that's going to host your servers and your network and things like that, you have a much better understanding as to what's going on and why. Common code. Let's go through a scenario about the problem of using common code. So let's pretend we've got two different microservices and they are using the same NuGet package for that common code. Now, I agree with the don't repeat yourself, and you should have common code, but to an extent. And this is what this demonstration is meant to convey with this. So the team A has made a change to that NuGet package that is central to both teams so that they could get another version of their microservice out to public or production. Then the problem comes is that, well, team B finds that that change is a breaking change for them. Well, so what has to happen is, in order to keep these code changes from hurting each other, is at some point you're going to find the code that needs to be duplicated and split apart so that the microservices can evolve independently. So earlier they were tied together at the code level and it became a tight coupling issue. So team A says we're going to pull out and create our own package on the side for things that was duplicate, but also evolved away from that duplicate. So now you got two teams with two different microservices using two different specific NuGet packages, but they're not necessarily duplicate. They were at one time. Now I apologize. They were one piece of code at one time. Now they're pulled apart and duplicate, but then they are no longer duplicate because even it evolved independently, and now they're not tightly coupled at that level. And quick question for you: that NuGet package there in the middle, who owns it? See, we know which microservice is owned by which team, but when you have a common code, well, who's responsible for it? If anybody can do it, well, then obviously it can change at any time, and there's that danger with that. So you want to be careful. So the rule of thumb: separate the code that needs to change to its own package for the service that needs it. And I already crossed that bridge as to who owns it. Okay, so despite best efforts, you decide, hey, I'm still ready. I'm going to go do microservices. So you're going to go jump in, you're going to find a piece of code in your monolith, and you're going to pull that out to a new microservice, but then you realize it has a dependency. So you're going to keep going. You pull more code over and you keep going because of other dependencies. And you end up with not another microservice, but instead you ended up with yet another monolith. So I mean, this is something to be avoided. But at the same time, if you're still on your way to microservices and you're able to put this technical debt into your backlog so that you can address it, and this monolith number 2 is still, even though it may have to go to production like this, but it's going to still turn into and evolve into microservices, maybe in the next few sprints, well, fine, then you can tolerate that a little bit better. But if you just stop here, you really didn't gain that much. So if it's a stepping stone on your way, fine, but continue on to microservices. Else you've probably hurt yourself, and you probably should use feature flags and just make multiple instances of that monolith using that feature flags to govern what it processes. All right, another rule that has come about regarding microservices, and I disagreed with this one at the time, and that is, if a microservice is responsible for persisting data, then it should have its own database. Now, like many others, I grew up with the central data repository, and you don't just split that out just because you have a microservice. It did not make sense to me. It does now, and this is what this is for. And so we're going to go through this scenario. Imagine we have a monolith with its central data store, and it's got tables for accounts, customers, orders, order history, parts 1, shipping history, and logging. Oh yeah. Sorry about that. Parts 1. Well, okay. So here's the deal. So as this program has evolved over time, well, the parts table has had additional columns added to it, right? So now the parts table and others, their schema grows, it changes over time. And then at some point, well, it figured out, well, okay, we got to make some changes that are going to be more problematic. So we'll just create another table and we'll call it parts 1 because, well, naming is hard. Yeah, hopefully I'm not the only one that does that. So that right there is showing the problem. When we have just as our code changes over time, so does our data schema. When we change our models, then we're going to end up with this problem where we're going to have this application needs these changes, but this other applications need these other changes. And so we're ended up with this issue. And certainly when we get into microservices, well, how do we deal with that contention at the schema level? This is what why we're going to walk through this scenario. So now we've got our monolith there on the left, and it's got its central repository, data repository, but we build out a parts microservice, and we also build out an orders microservice that has a reliance on parts information. Then we go a step further. We have built in a shipping microservice that has dependency on orders information. So shipping is relying on orders, orders is relying on parts. Now, what you could do, and it is a solution, is that as the shipping microservice needs to work on processing some of the shipping and it needs order information, it can call over to the orders database and get that information from there. Okay, then the orders microservice says, well, I got to get some information about parts to fulfill this request. So it makes a call over to the parts microservice. And it looks up in its repository and says, I got all of this information, and it sends it back. Now, what you could end up with is additional latency, because now you have microservices calling microservices, and because they're across a network, you have that additional latency built in, and your network could also be very chatty. You want to be very, very careful about that. So another option then is to duplicate data. Just whereas we were talking about duplicating code, because the code's not going to stay duplicate for very long, and it allows the evolution of the different microservices. This is where you want to look at duplicating data so that a microservice can have a copy of the data that it needs, but just the data that it needs. So if we look inside our parts microservice and then we look at some of the things that it's going to store about a part, such as the ID to part number, to classification, the description, the manufacturer, the manufacturer's part number, what part number did it replace or replaced it, what was the discontinued date, etc. Well, the parts microservice needs to know everything about that, but the orders microservice does not. So for an order to be fulfilled and have its duplicate data, it only needs just enough duplicate data for its own purpose. So things like, all right, just the ID and a natural key, if you're going to use that, and a part number, a part name, and a description. So now it has just enough information for it to do its job, and allows that to grow independent. Now, obviously, we're talking about duplicate data. Well, how do you keep duplicate data in sync? So one option that you have is by using a messaging pattern. So if we have our monolith there on the left, and we have an orders microservice and a parts microservice and our shipping microservice, and let's go through a scenario that the administrator says, I'm going to add a brand new part to our system. So she pulls up the website. It's hosted by the monolith and enters the information in for a brand new part. Well, there's a message going to be sent from there, and it's received by the parts microservice, because the order and the shipping microservices don't care about a new part, just the parts microservice. So it receives that message about a new part. We got the new part message, and it grabs that information and puts that into its data repository, its data store. And then later, somebody orders that part off the website. And so an order is created. And at that time, the part information was already grabbed and sent to the user. So they, the customer, so they know what part to order. They make an order. So now a new order is created in the orders microservice. And the parts information, just enough parts information that was needed, was used to the creation of that order. And then somebody says, hey, there's a typo in the part description. All right, so they call up the admin, they let them know, they pull up that part information, and they update that part information. So they fix the typo. So now you've got a message out that, for update part information message. Okay. Well, not just the parts microservice is going to be interested in that. The orders microservice says, hey, I want to check on that, because if I have any typos to fix and I've already got a copy of that data, I want to fix that up as well. So now you've got two independent microservices, two independent applications that are going to react to that same message about that updated information. So you can use multiple messages for the various types of processes that need to occur. Perfectly fine. That's what they're there for. So this is a quick example of how you could keep your duplicate data in sync using messaging. So another option is to go even further, is by using Sagas. And a Saga, you can think of it as, well, we have an order. And so the order is a new order. And then the order is going to be, you got a pick ticket, and then it's going to be in the shipping area, and it's going to be shipped out, and then the payment is going to be handled. And so you can use a Saga to keep track of the state of that order. So you have a basically a built-in history of such. And you may also look at the also different types of data stores, such as if you want to use event sourcing to keep track of the changes of that order. So you might even apply that at the order microservice. Okay, shifting gears to a high-level overview. But first, are there any questions? Because I know I've been rambling really fast on a lot of things because there's just so much to go through. While you're thinking, I'm gonna grab a quick drink.
Yep. No questions in chat at the moment.
Okay. All right. I will keep going. Okay. So we're going to go through a process. And this is just a high level overview. There's really not enough time to really do a deep dive on this. That's a great topic for another discussion, another meeting, another time, because you can really spend a lot of time doing true decomposition. So we're going back to this purpose of having our monolith, and we're going to extract existing functionality out to a new microservice. Now, I don't know about you, but I have never had a monolith application I've ever walked in as a brand new developer, looked at this thing and went, wow, the functionality lines are so crisp and clean that this is going to be a no-brainer. It's going to be so easy to extract. What usually happens instead is that those boundaries of functionality versus another is not really clearly defined. And so you're going to have to spend a lot of time refactoring first to understand where can you split things apart. How would you do that? Should you use the strangler pattern and others to help understand where you can make your changes so that the existing code that is dependent on that functionality you're removing knows how to make a call to the microservice to get that same functionality handled. So suggestion, start with a small piece of functionality, because regardless of the amount of code that or functionality that you're going to move to a microservice, you're still going to have to set up the repository and set up the CI/CD pipeline. You're still going to have to decide what's the team structure going to be on this? What are the programming language of choice? Should we, and I forgot to mention this earlier, do we want to change the database type? Maybe we're relational over here, but now with this microservice and now with the change that we're doing with this, maybe we need to use a non-relational database. Let's see, we often need to track the state of something like an order. You just mentioned tracking that in the Saga. Can you talk about what service you see managing that Saga and providing UX for that? Well, let me see if I can tackle that at the end. And the reason being for that is because that is not a strong suit for me, but I'll still see if I can help cross that bridge here in just a little bit. So when you start with a small bit of functionality to build your microservice, you're going to have time and money and effort to build in that infrastructure and get that team developed, that you're wanting to start small so that you don't have this gigantic elephant to tackle all at once. And if you build out this microservice and then decide we're going in the wrong direction, then you don't have as much code changes to revert, if any at all. Okay, a scenario. So this company, Wham Bam, that produces fidget widgets, kind of like the one I got in my hand as I'm talking, they decided they're going to look into creating some microservices to handle some of the problems that they've been having. And we're going to talk about using domain-driven design, but that's not the only way. Domain-driven design works really nice for developing microservices, certainly as we talk about a domain and bounded context, etc. But it wasn't made to do microservices. So there's other ways of doing that. Okay. I mentioned event storming versus event sourcing. Event sourcing is a data pattern for tracking the changes of an entity. If you want to say like the order, for example, of an order entity, it changes from maybe it's a new order to maybe it goes to canceled, or maybe it goes to payment pending. Now it's shipped, etc. Versus event storming is a workshop created by Alberto Brandolini, and I believe it's eventstorming.com. Check that out. And it's going to workshop so that us developers get into the same room with these subject matter experts, that they're showing us on a whiteboard how things function, but it's also with kind of a bit of a rules. What I mean by rules is you can have these colored sticky notes so that you have using the different sticky notes, and definitely put up a legend so you understand the differences of the sticky note colors. But you have the difference between an event, a domain event, versus an actor, and various other things about understanding the existing business processes. And as you start to look on the whiteboard and understand, we've got this functionality over here separate from here, you see where things kind of work together and where they're entirely separate, such as accounting has very little to do with processing insurance claims, just to grab random topics. They might interact, but maybe on a call level, but they're not, the code of one does not have to be the same code of another. So as we're looking on the whiteboard and you start to see this functionality being built out, you can kind of understand the various domain models, such as production. The production one, and the reason it's the biggest one there is because Wham Bam, this fictional company, the main thing that it does, it's a production company. They're not a shipping company, they're a production company. They produce things. And as well, they've got to purchase raw material to create and assemble these products that they sell, and as well ship out. To go even further, then we also have inventory management, accounting, invoicing, and returns. So you have third-party integrations, maybe with other vendors that want to work with our system. And but you also have like accounting, invoicing, and returns, kind of that generic domain. Those were certainly for a production company. Most of that functionality could be purchased off the shelf instead of custom made. So with this example, production is going to have a lot of the heaviest production code developed for handling this production as a company. All right, so as we look on the processes of things and the business processes, and we start looking at various things, one of the things we notice is that we have in our domains, we have production domain, and we're looking at purchasing domain, and we understand various items in there, such as parts and vendors, and then production has parts, orders, and products. So, and as you're starting to look on the whiteboard and you're starting to go through this and to kind of understand, one of the things that pops up as a need for clarifying terms, such as parts. Well, are we talking about purchase parts? We're talking about production parts that are assembled and sold. So with domain-driven design, you have what's called the ubiquitous language. This is where you come in and change your language so that you remove ambiguity. And by using things like purchased parts versus assembly parts, you can have the same language with not just the programmers, but also the subject matter experts that are in this every day. They can immediately know what exactly are you talking about. As well, with the ubiquitous language, it's not just about naming a term just to remove ambiguity. You want to also encourage this through the naming of our namespaces, to our class names, to our method names, so that any developer brand new to the project can look at this and immediately go and, okay, I am in this domain of this code, and I know exactly that I'm dealing with assembly parts versus purchased parts. Oh, nice. You had a meetup session on event storming already. That's fantastic. I want to hit you up about some contact information, so I'd love to have them do a talk over at my group as well. Okay, so as we're evaluating,
same guy that just asked you the Saga question.
Oh, okay. Oh, awesome. Okay. So as we're looking at understanding our bounded context, and so when we look at our domain, the production domain versus purchasing, and we see that we could draw a circle. Now, obviously this example is real quick and it's very, it's very simple example that I'm talking through. So when you're identifying your bounded context, that's relatively easy to do. Like we see these are the functionality that belongs as production that has very little to do with purchasing. And here these purchasing are there on their own. And as you draw these imaginary circles around the functionality, you're building or you're highlighting what is your bounded context. So now we're going to go a step further into the production bounded context. And we're going to look at some items that we see in here, and that is for order and products. So now we're starting to get into what's called the aggregates. And the aggregates, you can think of them as your class objects. So up until now, it was, just kind of understanding how things work together at a business level. Now we're getting into closer to code level. So with our aggregates, we understand at a class level. So we have orders that are made up of order lines, and we have products that are made up of the assembly parts, such as we buy this raw material, the purchased parts. They're assembled into larger pieces, and then they're finally turned into a bigger product. For example, I used to work at a air conditioning company here in Tulsa. And so they had this raw material. We got a lot of aluminum coming in, et cetera. And then they're going to build another part out of it. Well, they don't sell that part individually because they build up this gigantic chiller, and that's what's being sold. So that's where I got the idea is you can have raw material to assembly parts that make up a final product. So as we look at our order with our order lines, and we have products with assembly parts, and we see them at a class level, and we know that we have data that is about the assembly parts. We have data about the product. We have data that is about an order line and an order. So one of the rules in domain-driven design regarding aggregates is that any code in an aggregate can call functionality that exists in another aggregate as long as it goes through the aggregate root. And that aggregate root is defined as that top level class. And here's why. Imagine we got code for managing order lines, and it decides to do a direct call over to the code that handles assembly parts. What you risk is data integrity, because now other things may change the data that the other responsible classes like product is not aware of. So if you can think of it as we have these private functionality out of the assembly parts, and we have public functionality at the product level, then any other code can call, but has to go through the front door. And that way product can help with the data integrity of assembly parts, and may even say, you're calling, but I'm not going to allow this update to occur, or I'm going to allow the update to occur, but I also have to do these other steps that go along with it, such as activity logging, log the fact that it occurred, that call came in, etc. So by sticking to the rule that any code in an aggregate can call code in another aggregate, so long as it goes through the exposed functionality in the aggregate root, you do not risk data integrity problems. You help keep that data integrity intact. So that's a very quick bit about aggregate roots. So now we're looking at this, and we've got this functionality for order and order line and product and assembly parts. So we know we've got our class levels, and we have our aggregate roots, and we know what functionality that we want to expose and expose together. So now we can identify possible functionality exposed by a single microservice. Okay, so now we have a microservice that has one bounded context for production management, such as you may maybe expose some functionality such as assemble parts, assemble products, insert an order, revise an order, things like that. Now, I say possible because you may look at this and go, I would still separate them. That's great. That's your call. You should look at things like this. And this is a very simple contrived example as well. Now, you notice that the production microservice is basically exposing what you want to publicly expose of that functionality of that production bounded context. So there's also another rule about microservices regarding bounded context, and that is that a microservice can have one or more bounded contexts available inside it. But what you will not have is a microservice that has a bounded context that is shared across multiple microservices. This is going to create tight coupling. As well, who's to say that one microservice is owned by one team that the other microservice might later be owned by a different team? Well, if you have tight coupling, you're going to exacerbate that problem and have so much more to fight. Now, there is one exception to this, and this is if you have a bounded context that is for cross-cutting concerns. So far, I'm talking about the bounded context that deals with business logic. But what if you've already agreed, and this is across every microservice, we're going to use this logging solution and this log aggregation solution to be what is regardless of the application. So things like cross-cutting concerns is in its own bounded context, and that can be shared across multiple microservices. So logging, maybe telemetry gathering, things like that. Yeah, it could be across different programming languages, but if you're still going to use um, a log aggregation tool, maybe it's Sumo, something to that effect, it gives you that option. Okay, we're at the end, so let's do a very quick review. Microservices are hard. And I love that just because it's a nice reminder that be careful jumping into this and thinking you're going to conquer the world real quickly. There's so much more involved in doing them and doing them well. It is an independent application, and part of that love and attention that it needs goes with what kind of communication are you going to use? Is it back to the RPC, that remote procedure call? Are you going to do it direct? Are you going to do synchronous calls, asynchronous calls? Should you use messaging patterns? Or a combination of, you may have one microservice that is both doing RPC and messaging for the various business processes that it needs to deal with. Got to build out your CI/CD and repo per microservice, and be careful for your code that it could be tightly coupled. If you get in that spot where you find that there's that contention at the code level, go ahead and duplicate code and allow that duplicate code to evolve independent. So they're not going to be duplicate for very long. Get to understand a little bit more about networking, such as layer 4 and layer 7 specifically, and look at securing your communication between the microservices and the monolith, even if it's on a private network. Still pretend like it's processing your paycheck. You want to secure that. Even govern who can call that microservice. Maybe something like OAuth is used for that. Maybe use another mechanism. And then we touched briefly on a domain-driven design. It's not the only way doing building out your microservices, but it is a decent it's decent for you to use domain-driven design for the creation of microservices. And with that, you can better understand your bounded context and your aggregates, aggregate roots, etc. Some book suggestions that I have: Microservices Patterns by Chris Richardson, Domain-Driven Design, Tackling the Complexity in the Heart of Software by Eric Evans, who created domain-driven design, and Patterns, Principles, and Practices of Domain-Driven Design, which is PPP of DDD, by Scott Millett and Nick Toon. Also, when we talk about decomposition, I highly recommend Monolith to Microservices by Sam Newman. I cannot recommend that book enough because of the fact that it covers so many different ways, not just the strangler pattern of moving your functionality from a monolith to a microservice. And I do need to update my slides, but my book is out on Pro Microservices and .NET 6. And where we talk about, in fact, this talk came out of me developing chapter 1 of the book. So we do get into a lot more of the details as far as microservices. Now, in one realm, though, it is high level, such as in chapter 3, we do talk about domain-driven design, event storming, etc. And even in chapter 6, we talk about splitting, decentralizing your data into different data store types. And there's various patterns that you can do with that, such as event sourcing, and CQRS, the command query responsibility segregation. And then we talk a little bit on direct calls, as well as messaging type patterns. We talk about testing and also the health of your microservices, if with open telemetry. And so now that once you get your microservices out there in production, how do you know it's doing well? How do you know when it's time to scale? And so we cover that as well. All right, that is it for me. So let me go back to the other question. We often need to track the state of something like an order, and you mentioned tracking it via Saga. Yes, the Saga is one way you can do that. I definitely not a great expert on that. So I hope that I can give you some decent form of an answer. You want to use a Saga for the purpose of dealing with changes of an entity. So if you think of an order as an entity, then versus another one, it allows multiple microservices to still be independent, but yet connected at the business process, and that business process of an order specifically, so that if if something about that order changes and now shipping needs to know about it, what if that order got canceled? Then the shipping microservice may need to know about that. So hopefully that covered a little bit that on that. As far as providing a UX for that, I don't have an answer specific to that.
Well, I was thinking more in terms of, sure, there's the scenario where the order gets canceled, but there's also this scenario where the customer wants to understand what the state of the order is. Like, is it at, getting ready to be shipped? Has it shipped? That sort of thing. Are you looking at the production or the shipping service issuing events that the entity that owns that Saga is listening to update the state?
Yeah, that's a good call. Let's talk on that a little bit later here in just a few minutes. Maybe we can dive a little bit further into that.
Sure.
But because you might be, like I said, I'm not a great expert on that, so you might be able to help me on that instead. So, but I definitely want to talk about that. Defining bounded context boundaries is the defining your bounded context boundaries domains is the key to design of microservices. One criteria is that update transactions cannot span bounded context. Yeah. Yeah. So, and yeah, so that when I've heard that rule is that if a microservice, and I've kind of tweaked it a little bit too, is that because the one I heard was a microservice should have its own database. It's like, well, not every microservice actually persists data. So maybe it's just there to do some calculation, and it doesn't persist anything. Okay, well then it doesn't need its own database. But if there is a responsibility for housing that data, then or persisting that data, then it should have its own database. Now, that's very arguable, certainly with a lot of database administrators, because that doesn't necessarily mean its own hardware. It can be, if you want to go from SQL Server to Cosmos, that's an option. If you have the need to go from a relational to a non-relational, go from maybe an on-prem hosted thing to a cloud. It gives you the opportunity to do that. It's not saying that you have to do that. Other ways you can do that is, excuse me, you may still stay in the same database server, but you may use a different schema. Even in SQL Server, you can have the DBO schema, but you may also use another, create another one just to help split it, so that you're also splitting you're segregating your permissions on the different schemas. That's good enough as well. The whole point is, don't allow the requirements of one application to cause contention of another application that is reliant on that same data. That's where we're going to fight, is that when they have that contention at the schema level, just at the, like is possible with the same shared code level. So should you use a different database? Should you use just a different schema? Should you use a different server altogether? That is to be discovered through the process of deciding if a microservice is really right for what you're trying to accomplish. So that is, I'm glad you brought that up because I know I kind of flew really fast on that. But it gives you that opportunity. So hopefully that covered that well enough. Any other questions? All right. FYI, when I was talking about networking, tomorrow night, I'm giving a talk in Louisville about network fundamentals for developers. And I'm giving that same talk at my user group next Tuesday night. This is going to be, next Tuesday will be our first time back in person after a couple of years. But I'm going to try to do it as a hybrid. You're more than welcome to come check that talk if you're interested. And so there's also, you're welcome to come to Tulsa if you want, but there's also a WebEx link there as well if you RSVP. So check that out if you are interested. Okay. Anything else?
Okay. Well, I'm going to go ahead and stop the recording, Sean. Thank you again.
Okay.
Really appreciate it.
Yep. Thank you.